We are going to start the course nanotechnology chemical engineering. So today we will discuss about the synthesis of MOF and aerosol type of materials. So these materials are nanoporous materials. So out of this, in our previous class we already have discussed what is called porous materials, different type of pores, how we can categorize the pores that is present in porous materials. So depending upon that dimension of the pores, we can classify it as mesoporous, macroporous or microporous materials depending upon their pore dimensions, and all pore dimensions is nano range. So now MOF type of materials and aerosol type of materials. So these are the materials also available in, we should study that. So in MOF type of materials, so here this is crystalline type of materials and it consists of specific metal ions that may be depending upon that precursors we are started with. So depending upon that metals, whether it is nickel, copper or irons or whatever the materials, the initials nitrates or chlorides precursor that we have taken, that is inorganic materials that we have taken, and with that some organic linkers that we have to use, that is organic compounds that you have to use as a linkers materials to develop these highly porous crystalline micro MOF type of metal organic framework type of materials. Okay. So this type of materials, why we are interested? So because this type of materials having exceptionally highly porous and high specific surface area. You can see here 500 to 7000 meter square per grams of these materials, this MOF type of materials. Extremely high surface area is present in this type of materials. Therefore, this type of material sometimes acts as a catalyst or catalyst supports materials we can use. A different type of means gas absorptions, in CO2 absorption, CO2 storage. So there also means lot of applications are there from chemical engineering point of view. So therefore, these are the materials we should study, how these materials can be synthesized and what are the various structures, different type of means MOF materials are available. So that will discuss. Okay. So the property of the materials already have said, high surface area, exceptional porosity is present. So this structural flexibility, this type of materials having different type of pores, different type of size of the pores, shapes of the pores that is available. So that is helpful for different type of gas adsorption reactions. So there are gas storage. So that can be used since it has this type of means structural property, means high surface area and high stability also, means the materials that would form. So structure of this particular materials can withstand temperatures not extremely high, but temperatures of 200-300 degrees centigrade that can be sustainable. So for adsorptions, gas adsorptions purpose, so the temperature is extremely high. So means that materials having thermal, chemical and mechanical stability is there. Also functional diversity, means that materials whatever we synthesize, different functional group also we can develop in that type of material. So that would be good for a specific reactions or applications. So therefore, depending upon that materials synthesis and interest of that material, depending upon their applications we can prepare. So I said gas storage, gas separation, CO2 capture, hydrogen storage, methane adsorptions, many applications are there. Gas storage and separations, it can be used this type of MOF materials. Also I said it can be used as a catalyst materials. Catalyst in heterogeneous catalyst is there many reactions where we can use this MOF material as a support materials or reactants also. So due to their exceptionally high surface area and the active sites of the catalyst that can be distributed over this MOF surface. So that can be used. Even sensor drug delivery, there also it can be used for the detections of the different toxic gases components that is present. We can control that also. Water purification, there also it can be, these materials can be used to remove the heavy metals that is present in wastewater or different organic pollutants that is present, that can be used, or that particular applications there we can use. Now is the synthesis of this MOF type of materials. I said one inorganic materials or precursor, that is metal ions you have to take, another organic ligands, organic materials you have to use. Both we have to react in a particular reactors we have to choose and theirs we have to use, and then after that this type of MOF structures would form. So, here these organic ligands that actually acts as a bridging ligand or linkers, and these metal ions depending upon that different type of MOF, metal MOF we can say. Okay. So, these metals may be different type of metals, metal single ion, double ions, depending upon that metals we are going to use to prepare that particular MOF. So, in organic linker or the organic ligands, that may be different carboxylic acid means functional group are present, or maybe anions, or maybe organophosphorus type of compounds, salt of sulfonic acid, heterocyclic compounds may be these ligands or linkers. Okay. So, here a few linkers MOF to synthesis MOF organic molecules that can be used. So, here dicarboxylic acid, tricarboxylic acid, tetracarboxylic acid. Okay. And this is imidazole, that is nitrogen is present in this type of molecules, that also can be used as a organic linker to prepare MOF. Okay. So, different type of metal ions, metal salts we can use, chlorides, nitrates, that can be used as a source of metal ions, and organic linkers. Here functional groups you can see this type of dicarboxylic type of groups are present here, 1, 2, 3. This type of means tricarboxylic acid or dicarboxylic acid, maybe we can consider. There are many type of or varieties of organic molecules are available, so that can be used. Here tetracarboxylic functional groups are present. So, this we can use. Here tricarboxylic acid is present. So, okay, so different type of organic linkers we can use to synthesis MOFs, and depending upon that these linkers use different groups. That MOF means these are the all are MOFs, but depending upon the different research lab that have been developed, depending upon that IR MOF, UIO 67 different. UI means University of Oslo, they have developed this. Depending upon that it is abbreviated like this. Okay. Metal organic frameworks, all are similar type of compounds, but organic ligands metals are different, and depending upon that they have used this type of means abbreviations. Even I said different nitrogen atoms are present in a precursor. So, this type of imidazoles type of compounds, so we can use as a to synthesis MOFs. So, then we can GIF zeolite imidazole framework type of things or MOF formations is there. So, this type of also CPL coordinations polymers with pillared layer framework. So, that also CPL F MOF ones. So, these are different type of MOF, that also different research teams that have been developed, and depending upon theirs that has been abbreviated. Okay. The MOF means different linkers we can use, different inorganic precursors we can use, and once it is forms after condensations in a particular reactors, when it would be prepared. So, then it may form different type of structures. So, more than 20,000 structure has been developed, different type of MOF has been prepared. So, MOF exhibit various structural shapes also, triangles 3-point connectivity, or square paddles 4-point connectivity, trigonal prisms that is 6-point connectivity, octahedrons that is 6-point connectivity. So, depending upon that, so we can also the different structural shapes we can categorize it. Also role of organic linkers, I said ditropic, tritropic, tetratropics or multitropics organic ligands that is present in MOFs, depending upon that. So, that metal actually here the metal ions, so that metal ions will be linked with that different sites available in the linker. So, that will attach over there. Okay. So, depending upon different type of means sites available, the metals will link with that. Okay. So, here different type of structures, so many different type of structures are there. So, I said more than 20,000 different structures that can be possible, and different labs, different materials they are preparing. A lot of different structures that has been developed, or materials has been developed and structure has been proposed. Okay. So, next is the synthesis of MOF. So, basic things we have discussed. Now, few methods. These methods is very simple method we can use to prepare MOF. So, once metal ions we have to take, another organic linkers we have to take to prepare that particular MOF. Okay. So, this is the basics reaction. So, here's depending upon the source of heating. So, microwave assisted methods, electrochemicals methods we can use, or solvothermals or hydrothermals. If we use water, then it is called hydrothermals, or if you use any solvents during this process, means MOF formations, then that solvothermals we can say, but heatings we have to do by normal heatings, and mechanochemicals methods, sonochemicals methods. So, these are the different methods are available. So, that use during these condensation reactions. So, depending upon that the structures formations would be different. So, that you can see here, first one is the microwave assisted method. So, in this particular method, so here's one Teflon vessels that was taken. So, within that the substrate, that is the metal salts and organic linkers, both will be taken here, and after that Teflon vessels that will be placed inside of that microwave, and their microwaves will assist in the condensation reactions. Okay, that will interact with the solvents and the linkers or ions, metal ions, and different type of means frequency we can use. So, this is the rapid crystallization process. Nanoscales materials formations is there, high purity and highly selective. MOFs, polymorphs can be synthesized through this process. So, here is called microwaves because heatings that would be with the help of microwave irradiation. So, that is why that is the change, nothing else. So, microwave that will interact with the solvents that is used. So, this type of structures at the end will get. Then electrochemicals method, that is also electrochemical cells will be taken. See, here's the metals, instead of metal precursors as the electrode, one of electrode that metals we can take, and then electrochemical cell organic precursors or linkers will be placed over there in that solvent, and some reactions will take place. Okay, so then means metal that will be forms in the metal ions come into the solutions, and then electrolyte solutions is the electrolytes is there, KCl here it has been used. So, then with linkers that will forms, means metal ions interact with that linkers and forms MOF. This is in this process sometimes hydrogen formations is also there as a byproduct. Okay. So, in this particular process, this process is more efficient than conventional batch process, but higher solid yield and control MOF formations that is possible in this particular process. Next, solvothermals or hydrothermals method I said. So, when water is used for this particular process as a solvent, so then it is called solvothermals. Any other solvents we can use, protic solvents we can use to prepare this particular MOF materials. So, here's few protic solvents it is given that can be used in this particular method or synthesis of MOF. This is the MOF structures I said in a Teflon, this is Teflon vessels we have taken. So, Teflon vessels that will be placed inside of a autoclaves, in SS autoclaves. So, inside of that autoclave, so there's this is Teflon and this is autoclave made of SS, and this is made of Teflon. So, here's we can take precursors and salts, and that would be placed, these mixtures will be placed inside of these vessels, and then we can maintain some temperatures, and then high pressures, high temperatures developed inside of these vessels, Teflon vessels, and then reactions will take place, and then MOFs will forms. Okay. So, after that we can separations, filtrations, separations, that solid residue left that we can collect as a, and then evaporate that solvents. Okay. So, that way we can prepare. Then mechanochemicals method, that is also another method. So, this is solid state reactions will take place. So, here we can take one mortars, this is mortars was taken, here metal salts and organic ligands both were placed, and then pastels without solvents. So, then or else we can use ball mills also we can use. In ball mills is theirs, a closed vessel is theirs we can, this is different number of balls are used, there's metal salts that would be used plus linkers, organic linkers, and milling process means without any solvent, so we can mill, and then condensation reactions will take place, and then after that we can remove if any waters or other things are present, so we can take. So then at the ends this type of MOF we can form. Next is the sonochemicals methods. Here is also similarly in a beakers we can take metal salts and organic ligands, so both will be placed here, and after that ultrasonic wave at different range that we can, this is ultrasonic wave, so that we can place, and then that would helps in the formations of bubble formations. That bubble formations should be there here, and then bubbles will be collapsed here, bubble formations with some turbulence will be created with the help of ultrasonic wave, and then bubble formations should be there, bubbles will be grow, and then that would be collapsed. So during that high temperature, extremely high temperature and high pressures will be developed inside of these vessels or here, then that would help in the reactions and structures developments. So then this type of MOFs we can prepare. Okay. So different type of methods, 5-6 methods we have discussed to prepare the MOF. So each particular MOF method of synthesis having some advantage, disadvantage too. So here let us say microwave assisted methods, it has advantage, these are, and these are disadvantage. So and solvothermal methods, these are the advantage, one step methods, and these are the disadvantage, long reaction times, 24 hours, 36 hours, 48 hours we can wait for solvothermal method. So that is the disadvantage. And microwave assisted method, that is rapid crystallizations, the time is required very short, that is the means advantage. And electrochemicals methods also, metals are not required, here's electrodes that metals we are using. So here's that is the advantage, instead of any precursors, inorganic precursors, we can directly metals electrodes that can be used, that will be dissolved during the reactions. So here's yield would be in this process, the product yield would be very low concentrations or low yield, mean the product yield would be very low. So that is the disadvantage. And mechanochemicals method, so ambient temperature that we can prepare and less time consuming, eco-friendly this process, mechanochemical process, but decrease the pore volumes and lower crystallizations in mechanochemical process. And sonochemical process, that also advantage is there, that is quick and we can make it room temperatures. Okay. And disadvantage is single crystallizations is very challenging. Okay. So influencing factor, different influencing factors. So when we are preparing MOF, so then organic ligands that we have to use. So that where we carboxylate acid groups are present, or maybe nitrogen containing heterocyclic atoms or molecules we can use, phosphoryl sulfonyl linkers, so that may be present, determine the coordination patterns. So depending upon that linkers, that helps to determine the coordination patterns that will forms during MOF synthesis. Next is the salts, that I said different type of salts we can take, either carbonate, sulfate, nitrates, or organic, that is acetates. This type of metal salts we can use to prepare that MOFs, and depending upon that salt, its morphology, topology, stability and surface area will change, or that will forms depending upon that. Molar ratio also, concentration is also very important. So the linkers and metal ions that will be taken to prepare the MOF, individual metal ions concentrations is important. So either one metals we can use, two metals we can use for that particular type of preparations, and its concentrations with ratio also with the linkers is very important. Okay, so that alters even pH of the systems, means when we preparing the MOFs in a particular method of synthesis, then means pH also importance. pH also change the structure, colors or adsorption properties of the MOFs that will be prepared. Even solvent, I said different type of solvents, organic solvents we can use, water we can use, that also will change the structure, coordinations, behavior of that MOF that will be prepared. Temperature impact, temperature also important. So if we use high reactions temperatures, then that would, as a result, crystallinity means highly crystalline MOFs will form. Depending upon the temperature also we can vary. Okay. So, here the some properties means pore size that will be developed and the specific surface area, that is extremely high surface area that we can develop. Pore size also will forms. So, here I said the solvent effect is also very important. So, aprotic solvents we can use, that is DMF, or water or ethanols, that is protic solvents. Individuals aprotic or protic solvents we can use. If we use aprotic, this type of structures, this is for an example. So, here if it is protic, this type of same MOF, but different structures it forms. When DMF and methanols is mixed a certain ratio, these are the precursors, means magnesium, and these linkers, organic linkers that is used. So, this type of structure formations is there. When DMF and ethanol is used instead of methanol, this type of structure is formations is there. So, depending upon that, solvents is also important. So, also structural changes, means different type of structure would forms in same MOF materials. Here metal was the magnesiums and this was the linker. So, the structure is different. Okay. So, I said what are the different properties that we can use, means metal ions, ligands, synthesis conditions, temperature, characteristics. These are the things we can, means tunes to control the structures of or various properties of that MOFs, either it is surface area, pore size, pore volume, crystal size, or catalytic activity, depending upon the applications. Okay. So, we can thermal stability also. So, these are the other mechanical property, electrical property also, that would vary depending upon the particular precursors reactions conditions we are using. So, here is the application. So, where we can use MOF: gas storage, gas delivery, drug delivery, rechargeable batteries, supercapacitors, MOF membrane for wastewater treatments or water revivals. So, there we can use a particular MOF, and catalysis, sensing for a particular sensor preparation. So, there also we can use MOF. Okay. So, today is up to this. So, today we discuss about how MOF can be synthesized, a particular methods, and what are the various parameters, how we can control the structures. Okay. So, that has been discussed. Okay. Thank you. Today is up to this.